Question, what does it mean for two objects to be similar? What would you say if you were asked, what does it mean for two objects to be similar? Yeah.
Same shape, different size.
Okay, same shape, different size. Okay, and I'm just going to say same type of shape. As in, can a cylinder be similar to a cube? No. Okay, but a cylinder can be similar to a cylinder. A cube can be similar to a cube. A triangular pyramid can be similar to a triangular pyramid, but a triangular pyramid cannot be similar to a square pyramid. Okay, so that they have to have the same type of shape. All right? So how do we know if two objects are similar? How would we determine whether or not they are similar? So for example, okay, we're going to come up on the review question at the bottom here, and we're going to determine which ones are similar. How would we be able to tell? Mike?
Ratio of the sides are equal?
There you go. So you can tell by the ratio of the linear measurements. Okay, and I'm using the phrase linear measurements, okay, in place of sides, just because since we're talking about 3D figures, you know, it could be radii, it could be heights, it could be, you know, apophthegms, it could be pretty much anything, okay? All right, so then what is the relationship between the side lengths of similar figures and their areas? This is from chapter 11. Anybody remember?
Isn't like A to B, is it, and then like A squared to B squared?
Love it, okay? So she said for your scale factor, okay, which is the ratio of sides, that you would have a ratio of A to B. But then the ratio of areas, okay, and in this chapter we're going to use the idea of ratio of surface areas, is A squared to B squared. So very good, she remembers that, okay? All right, so then all we're going to do at the bottom is we're just going to add on to that with one more thing. All right, so in the review example, it says to determine which solids are similar to the one on the left. So is A similar to the one on the left, or is B similar to the one on the left? We got one vote for B. You say A, one for each. B? B? B's are winning out. So why'd you say A?
Oh, the side lengths like 4 is to 8 and 2 is to 4.
Okay, so she says 4 is to 8. So always do the bigger number with the bigger number. And then she says 2 is to 4. So far the lengths have the same ratio as the widths, but do the heights have the same ratio? Is 2 over 4 equal to 2 over 2? No. So therefore, A is not similar to the one on the left. But if we compare B, 4 is to 6 as 2 is to 3, as the heights 2 is to 3. Are all three of those ratios the same? Yes. So therefore, B is the one that is similar. Okay? And so that's what we mean by the ratio of the linear measurements. Okay? Have to be equal. Okay? So it has to be true for everything. The radii have to equal the heights in a cylinder. The apophthegms have to be same as the side lengths in, you know, like a pentagonal prism. All right? So in this case, in the case of rectangular prisms, your lengths, widths, and heights all have to have the same ratio. Okay? All right, so we did a big little chart back in chapter 11. Okay, we're going to do it again. All right, so we're going to start with scale factor. And remember, the scale factor is the ratio of your sides. Okay, if it has a ratio of A to B, well then the ratio of areas, okay, and that would include surface areas, okay, is also going to be is going to be A squared to B squared, as we just said. And then the ratio of volumes is going to end up being A cubed to B cubed. Okay, so that's really only the new thing, okay, is that the ratio of the volumes is A cubed to B cubed. All right, page 28. So we're gonna take this idea and we're gonna apply it. All right, so the cans shown are similar with a scale factor of 87 to 100. Find the surface area and the volume of the larger can. All right, so first thing, anytime they give you a scale factor, if you can simplify it, simplify it. So can 87 over 100 be simplified? And the only reason is it makes it easier when cross multiplying. All right, sounds like it can't be simplified. All right, so we said, based upon what we did in the our notes on the previous page, that for surface area, A squared is to B squared as the surface area of A is to the surface area of B. In chapter 11, we did A squared over B squared equals area over area. Okay, now it's just S and S. So in our case, we are going to do 87 squared is to 100 squared is to the surface area, and it looks like our surface area is 51.84. Okay, 51.84. And something I didn't do in chapter 11, but I'm going to do now, is I'm going to write in inches squared. Okay, and then over the surface area of the larger can, which I don't know. Okay, and that is also in inches squared. Okay, the reason I'm adding in the inches squared is because I want you to look at your problem, and in order to know that you're doing it right, is see squared, 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 squared. Okay, and the reason is, when we did this before, people were doing 87 over 100 is equal to 51.84 over the missing area, and that's wrong. They were not squaring these numbers, okay? So keep that in mind, that you have to square your A and B, all right? So do that. So in order to help you with that, okay, maybe think about making sure that you have your squares everywhere, okay? And then that'll just kind of keep in mind. All right, so then from there, all we got to do is just cross multiply and solve, okay? So you're going to have 100 squared times 51.84 equal to 87 squared times your surface area. You're going to end up dividing by 87 squared. So on your calculator, you're going to simply type in 100 squared times 51.84 divided by 87 squared. Tell me what you get. 4.49 inches squared, okay? So the key concept here is just, again, making sure that you square and square on your scale factor, okay? All right, so for the second part, we got to find the missing volume. So we're going to do A cubed is to B cubed is to the volume of the smaller can, 28.27. So 28.27 inches cubed over the volume, which is also going to be inches cubed. Again, make sure you got cube, 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 cube. Okay? So when I go to do this, I'm going to end up with an 87 cubed over a 100 cubed equal to 28.27, okay, inches cubed over a volume. Do not cube the 28.27. It is already cubed. That's why it has the inches cubed on it. So again, all you're doing is cross multiplying. If you need help doing the cube, reminder, there's two ways that you can do it. You can use the caret with the cube, or you can go to hit the math button, and then number 3 is a cube. Okay, however you want to do it. Okay, so we're cross multiplying. We're going to have 100 cubed times 28.27 divided by an 87 cubed. That's going to give us our missing volume. So 42.93 inches cubed. Questions there? Okay? All right, we're going to skip, example 2 for now. And we're going to go down to example number 3. Okay? And the only reason is because, sorry, I take that back. We're going to, let's go to the next. Okay, all right, so let's now go back to example 2. Okay, so on this one, cube C has a surface area of 216 and cube D has a surface area of 600. All right, when they're telling us information like this, okay, they're telling us 216 is to 600 represents A squared to B squared, because they're giving us the ratio of the surface areas. They're asking us for the scale factor, or what's A, what's B. What do we do? Square root. If we just simply take the square root and take the square root, we would figure out what A and B are. So, very simple. All you're going to do on your calculator is do the square root of 216 over 600. Type that in. Hit enter. It's going to give you a decimal of 0.6. Hit math, frac. What is 0.6 as a fraction? 3/5. So that means our ratio is 3 to 5. Okay? Does that make sense? All right. Now, they're going to ask us for the, that's the ratio. Now, that doesn't tell us what the actual side length is. Okay, so now they're telling us a couple of other pieces of information. Number one, that it's a cube. What do we know about all the side lengths of a cube? The length, the width, and the height. They're equal to each other. So 3 numbers, which are exactly the same number, are multiplying to be 216. What would that number be? Because that would represent the edge length. 72, you said? So 72 times 72 times 72? Or how do we find the surface area of a, 72 you said is the edge length. We need the surface area for the cube. Any ideas? How do we find surface area? Okay, how about this? We'll draw it out, okay? We got a cube, okay? And so what they're telling us is that this is the same as this, and the surface area equals 216. Well, don't we, to find surface area, do area 2 times the area of the base plus the perimeter times the height? Okay, so how do I find the area of the base? X squared. So x times x is x squared. Okay, how do I find the perimeter of the base if all the side lengths are x? 4x. What's the height? X. So it looks like my surface area, which is 216, is equal to 2x squared plus 4x squared, or 216 is equal to 6x squared. So can't I just divide by 6 and then take the square root? What's 216 divided by 6? And then what's the square root of 36? 6. So that means that the side length is equal to 6. Okay? All right, it says to find the volume of D. Okay, all right, so a couple of things that you could simply do here, okay? Number one, we know that the ratio is 3 to 5. The actual side length of the smaller one is 6. What's the actual side length of the bigger one? How do we go from a 3 to a 6? Times 2. So what's the actual side length of the bigger one? 10. So it wants us to find the volume of a cube, okay, that has 10, 10, and 10. What would the volume be? Area of the base times height. What's 10 squared times 10? What's 10 times 10 times 10? 1,000. Okay? So all they're trying to do is just make you work backwards a little bit, get you thinking a little bit here. Okay? All right, last one. Example number 3. The pyramids are similar. Okay, they're telling us that. Okay, the pyramid P has a volume of 1,000 cubic inches and pyramid Q has a volume of 216 cubic inches. Find the scale factor. All right, so key things that we're focusing on, volume and volume. Volume is A cubed, volume is B cubed. So if A cubed over B cubed equaled 1,000 over 216, they want us to figure out what A and B represent. What do we do? What did we do in example 2 when they gave us the surface areas and we wanted to figure out A and B? To get our 3 and 5. We square rooted. But now they gave us volumes. So how do we get plane A and plane B? How about cube root? Cube root, cube root. So on your calculator, do the cube root button. Okay, hit math. Number 4 is the cube root. That takes you back to the main screen. Type in 1,000 divided by 216. Hit enter. It gives you a decimal value of what? 1.6 repeating. Go math frac. What do you get? 5/3. Okay, so now you got 5/3 as your ratio of the sides or the scale factor. Okay? Questions? Now, big thing that I just want to emphasize is just because the ratio is 5 to 3 doesn't mean that the actual is 5 to 3. So in the previous example, we had actual side lengths of 6 and 10. So remember, it's just a ratio, it's not the actual. So sometimes you got to think about that when you're going to calculate things. Okay? Let's go to example number 4. Okay? This is the one I want to do. Okay? Only reason is because it's pretty much the same question. All right? So they gave us a scale factor of 3 to 2. Okay? They didn't picture both of the figures. Okay? But they gave us the scale factor, and then they gave us the surface area and the volume. All right? Our goal is to find the surface area of B, okay, and the volume of B. Understand that when they put it as 3 to 2, they're saying A to B. Okay? So we do the exact same thing. If I want to find surface area, I'm going to do 3 squared is to 2 squared, as the surface area of A is 324 pi inches squared over the surface area of B. You do the exact same thing. Okay? This time though, when you cross multiply, do not cross multiply with the pi. We're going to just stick the pi on at the end. Okay? So see if you can tell me what S is equal to. 144 pi inches squared. Anybody need help with that? Again, all you're doing is 324 times 2 squared, or 324 times 4, and then divide by 9. All right, so find the missing volume. Okay, all we're going to do is, pretty much the same concept except cube this time. So 3 cubed is to 2 cubed as, this time 972 pi inches cubed is to the volume. All right, cross multiply solve, tell me what you get. 288 pi inches cubed. Any problems with that? Big idea is just making sure that you're able to set up the proportion, and then from there, you should be able to go, okay? All right, so let's go back to